So let's start that. All right, if you guys are having any sort of issues with your audio, please go to the mic, and which is a little icon, and use that in order to set up the audio wizard. And in terms of the continuing education credits, make sure that you click any link that I send out near the end of the webinar in order to get those. For most of you, the continuing education credits should, and I say should, actually come up once you leave the webinar. For a few of you, that may not actually be, possible. So if that's the case, you can email at bpeterson@sref.info, and I will help you guys get the continuing education credits. I will put my email in later on. All right, so now we're going to leave things over to Dr. Sadoff. He is an extension educator and professor at Purdue, and he's going to talk to you about the emerald ash borer. All right. Remember to press talk, Dr. Sadoff. And correct me if I'm pronouncing your name wrong.
How about now? Okay.
Ah, here we go. You're on talk now.
All right.
I can hear you.
Well, good. All right. Well, listen, it is I'm very happy to be here to talk to all of you about emerald ash borer. And let's see if I make sure the buttons are working. Yes. Orientation, questions. Okay. So I'm going to cover a bunch of things today, and there is a message that I want to emphasize. I know a lot of you are new to the emerald ash borer game, and we've had it here in Indiana since 2004. So we're going on 14 years, and we've seen the emerald ash borer blow through the state, kill hundreds of thousands of trees. I've seen a lot of communities talk to me, and they've said to me they wish they took it seriously sooner. A lot of them thought that because they loved their trees and took good care of their trees would not be killed, and in fact they were sadly wrong. So we do have some tools for effectively saving ash trees, but if you choose not to save the ash trees will die, and when they die, they're very brittle. And if you have in the back of your mind that you've got a guy who could take care of it for half the price that I say in my examples, you want to be really careful about that, because cutting down dead and dying ash trees is a very dangerous business. They're very brittle. Just the vibrations of the chainsaw can cause branches to fall off in some cases, and people have died. So that's my serious note as a introduction, and now I'm going to go start with the substance of my talk. So first of all, I'm going to talk about how emerald ash borer kills ash trees, and then I'll talk about insecticide options, how to manage your invasion, how to get your community involved before it's too late, and then some summaries and some resources. Okay, so the latest news as of March 1st, to be updated probably in a few days, but we have emerald ash borer in 32 states and 3 Canadian provinces. And a lot of you in this part of the world here are fairly new to the game. But that doesn't mean you're not prepared. This is what emerald ash borer does. I took this picture in the middle of July in a golf course in Indianapolis, and you can see these dead, massive ash trees have been killed by emerald ash borer. It's a problem when you lose ash trees, because these ash trees have value. Some of you who may be a little bit new to the urban forestry world may not have heard of this, but there is a calculator called the National Tree Benefit Calculator at this link, treebenefits.com. And what it does is if you put in your zip code and your ash tree DBH, diameter breast height, it'll give you the value that it provides each year. Okay, so this is a useful piece of information when you're talking to city planners who want to know in concrete terms how much an ash forest is actually worth. I guess many of you already know what a DBH is. It's short for diameter at breast height, and what you can do is you just measure it at 4.5 feet above the ground, take your circumference, divide by pi or 3, depending on how accurate you want to be, and that gives you an idea of how big your trees are. When I talk about, so when you hear me talking about a 20-inch ash tree, I'm talking about a 20-inch DBH ash tree, not something that comes up to my knees. Okay, so this is the life cycle of the emerald ash borer. Right now, it is, I guess you can probably see this little magic pointer over here. Right now, we'll see many of the emerald ash borer are just beneath the bark. They're either in the J-shaped stage or they may be in the pupal stage. They will then come out of the tree and making their V-shaped exit hole in May. And then in late May and June, they will be mating. They will then feed on leaves, which is really important for the females to mature their eggs and get enough energy to fly from tree to tree. They will then lay their eggs. The eggs will hatch, and they will bore through the back of the egg into beneath the trunk, and they'll have these nice creamy colored larvae with these bell-shaped segments, and then they make their zigzag galleries and the cycle repeats itself. So how do these things kill trees? Well, they feed in the zone over here in the cambium and the phloem, and as they get bigger and bigger and bigger, they can actually etch more of this of the xylem. Okay. Now ash trees are ring porous, which means there's only one row of functional xylem over here that are the tubes that suck up the water from the roots and take them up into the leaves. So as they get bigger, they will etch this area and they will kill that portion of the tree. So you can imagine as they get, if part of a tree is killed and it cannot lay on new bark, when the other side of the trunk is laying on new bark, it pulls that dead part apart, and that's how you get these vertical splits in the bark, which is one of the telltale signs that you have emerald ash borer. And in this particular one over here, you can actually see the zigzag galleries beneath, and this is what it looks like when the bark has been removed. Okay, more zigzag galleries. Okay, and they pack their the tunnels with frass, which is a sawdust-like excrement. This time of year, I'm not sure if the leaves have come out where you are in the south, but this time of year where we are, there's not a leaf on a tree, and the most visible thing we're going to see are woodpeck holes. And when it's really heavily infested, you can actually see, it looks like, we call it blonding because the normally dark trunk has turned a light color because these woodpeckers are pecking and knocking off the bark in search of nice juicy larvae. If any of you have ever hung up a picture or something when you've done some work in your house and you're looking for a beam, you will knock onto a wall and hear a nice high-pitched area where you see a beam. Imagine the woodpeckers do the other thing. They will knock on the trunk until they hear a hollowish sound where they're likely to find a nice meaty little larvae for them to feed on, and they'll go right in there. And this has been a real difficulty for us when we do our research. We often have to cage our trunks so we can actually keep the woodpeckers from eating our data. Okay, so after you have you get into the season where the leaves are coming on, you'll notice that the upper canopy of the tree will actually thin on at first because this part of the tree has essentially been killed. And then as time goes on, more and more of the tree will be killed, and you'll see less and less leaves, and you get more and more thinning. Ultimately, as in this case here, what we see is the top part of the tree is really thin. There's very little normal canopy. This area over here, this halo, is what we call, these are called Epicormic Shoots. And basically what it is that the tree is dead at this point in time. And the tree is just trying to produce new shoots in the last gasp effort. And this is what it looks like. So you may have clients coming and talking to you saying, well, look, the inside of this tree is still alive. This is when you tell them, no, actually the tree is really dead. Because next year, there won't be a leaf left. All right. So once again, I want to say this, is that, if you have a guy who can do it on the cheap, who's not a professional, you are risking serious liability for you and and risking that person's life. Dying ash branches are brittle. If that tree fails, especially on some of these big trees, it can be deadly. Ash wood is quite heavy. We make tool handles out of it, axe handles. This is pretty tough stuff. Unfortunately, I'm aware of a number of situations where people have been killed by falling ash trees in Indiana and in the Ohio area. So this is something that should not be trifled with. So just remember the decision you can't ignore emerald ash borer. You either have to remove the trees or keep them alive, especially in urban areas. Risk, hazard. Those of you who may be certified arborists are familiar with risk training. In order for a falling limb to be a hazard, there has to be a target. So if that falling limb or the falling tree is in the middle of the forest where nobody walks and nobody's hiking, it's okay. The dying tree provides habitat for woodpeckers, wildlife, and a lot of decomposing animals. But if that tree is by a trail, or if the tree is by a park bench, or it is near your house, there's a potential target, and there could be a real problem.
Dr. Sedov, before you continue, we're having some reports that your audio is a little muffled.
How about now? Is it better?
Yes, now it is much better.
Okay. All right. Okay. I just have to. Okay. I guess my mic must have dropped down a little bit. Okay. So I guess what I was saying was that. Okay. I'll hold it here now. I was saying that you really have to either plan to remove your ash tree or have it treated, because that standing ash tree can cause a hazard when there's a target nearby. All right, now let's talk about some insecticide options. There are different ways of applying insecticides, and the way they mostly work is that the insecticides will be taken up by the tree, and they wind up being accumulated in the leaf, and when the beetles are feeding, it kills kills them. And then the other insecticides, will also be feeding, will also be beneath the trunk, and it will actually kill the larvae. So the poison cambium kills the larvae, and the poison leaves will kill the adults. And there are 4 different kinds of products that are available. Imidacloprid is useful for homeowners. But it will only protect trees that are less than 20 inches in diameter. Same thing for dinotefuran. Emamectin benzoate, there's no limit to the size of the tree that can be protected. And azadirachtin will protect trees of large size, but you have to start your treatment before damage has been found on the tree. So you have to really get there a lot earlier. All the products will kill the first and second stage of the larvae. Emamectin benzoate will kill all stages of the larvae, and it will also kill adults. So it's quite toxic. And I'm going to show you some work that was done by Therese Poland and Deb McCulloch that actually looked at compared the toxicities of the different products that are available. And imidacloprid will take, when the adults are feeding on in pesticide-infused leaves, it takes several days for them to die. Basically, it almost works as an anti-feedant. The larvae just don't like to eat it, and they almost just starve to death. So it takes them, almost 45 days for them to die. So This is effective and it works well on small trees, but it's not the most toxic product. Dinotephoran is another avoiding situation. The adults will die after eating a few bites, so it's much more toxic than imidacloprid. But the larvae are dying mostly due to lack of feeding, and what they're feeding on is poison. But they just generally don't like to feed on imidacloprid tainted tissue. Dinotephoran tainted tissue. Now, ivermectin benzoate is a whole other story. It only takes 1 or 2 bites of a leaf for an adult to be killed, and they readily eat the impregnated diet, and they die much more quickly than either when feeding on dinotephoran or feeding on imidacloprid. And azadirachtin is a different animal, but it's quite toxic to larvae, and they will readily feed on the insecticide-infused diet. It does not kill the adults, but it will just reduce their fecundity. So that's why, if you have a situation where you want to use this thing for, say, somebody who only wants to use an organic method, you would have to make sure that the tree is showing no canopy thinning, because you really have to get really good coverage in order to actually protect these trees. Okay, now, how does this work? This is some data I have from Dan Herms. He did this work in Ohio, in Toledo, Ohio, in the mid-2006, 2012. He started out in 2006 with these trees that were 14 to 20 inches in diameter in 2006, and none of the trees showed any canopy decline at all. Okay, 100% canopy decline means the tree is dead. 0 means the tree is perfectly healthy. Okay, 2007 there was a little bit of feeding going on. In 2008, all of a sudden the untreated trees have lost 40% of their canopy. By 2009, 90%, and by 2010, 100% of their canopy. Trees that were treated in the fall, they were treated in the spring at the normal rate, or in the fall at the double rate, all seem to be protected over the course of the study. But those that were treated in the fall did not seem to be as protected, okay, if they only had the single rate of product. But at any rate, so if you are applying this product in the springtime, okay, at the correct rate, at the 1x rate, or in the fall, the double X rate, you're going to get some fairly decent protection with this product. Okay. Now let's contrast that with the ivermectin benzoate. I have a study going on right now in Eagle Creek Park in Indianapolis, and I'm working on big trees. Okay, and these are 2 ash trees. This is my graduate student who's 6 foot tall, former graduate student at this point in time. And this tree on the left here is has a DBH of 39.5 inches. So that's a 40-inch spread across that tree. Okay, the tree on the left was treated. The tree on the right was not. It's dead. Okay, so those of you who are visual learners may find this slide quite convincing. Those of you like myself who are more data-oriented might want to look at this slide. We started treating so we had 30 trees in the study. Okay, 10 trees were not treated. We call those the control. 10 trees were treated in the fall in September. 10 trees were treated in the spring in June with ivermectin benzoate. We used 5 mils per inch DBH. We treated in 2013, and we treated again in 2016. Initially, the canopy thinning was all less than 10%, and we started noticing not much happening in 2014, which is good for the study, which means we got there early enough. But by 2015, the untreated trees had lost 60% of their canopy. 2016, they had lost 90% of their canopy. 2017, they lost 100% of their canopy. Those trees that were treated in the fall basically had the entire summer for the beetles to continue to feed, and there was damage. So we wound up having about 40% canopy thinning at its peak before the branches started falling off. The leaves started coming back in, and then those trees that were treated in the spring that had only lost 20% of their canopy and maintained that. So what this tells me is that big trees can be treated and they can be protected. It does not matter the size. and only at 5 mils per inch dBH of emamectin benzoate. Okay. Well, you know, in order to inject a tree, you really have to do it correctly. Sean Burnick and Tom Smiley have a really nice pamphlet that they put together for the International Society of Arboriculture, and they tell you tips on how to inject a tree correctly. It is always advisable to use a helical drill bit, which means it's shaped in such a way so you can get a nice clean cut. That drill bit has to be sharp, and your battery of your drill has to be fully charged. Because if it's not charged, what can happen is that your drill bit, a dull drill bit on a poorly charged drill, will probably grind that wood. It'll heat up, and it'll cauterize those holes, so you won't get the kind of uptake that you really depend on in order for you to protect that tree. So this is, for those of you who are getting involved in this, spending $10 or $12 to find out how to do it correctly would be well worth your while. Okay, so, you know, some of you might be plant pathologists. You always like to talk about plant triangles and all this sort of stuff, and triangles are nice ways. I think what I've done so far at this point is demonstrate that it's feasible to control emerald ash borer. And now I think what I want to do is I want to talk more about the financial justification, because a lot of folks are saying, well, why spend the money to protect a tree? We've got to protect the tree forever. We have done some modeling work that shows that it makes some sense to treat it. But before we do the modeling work, this is a good example of what I call back-of-the-napkin calculations. This is the 10-year cost estimate for protecting a 20-inch ash tree. If you wanted to remove and replace an ash tree using prices based on bids accepted by the city of Indianapolis, it'll cost $22 per inch to remove a tree and grind the stump, assuming that that tree is not near a target. That means this is kind of like a park tree, and it can be dropped down pretty easily. If that tree is next to a power line, if that tree is next to a house, you could sometimes triple or quadruple this cost. All right, and then if you replace it for $400, your total cost for 10 years will be $880. If you are treating at $10 an inch once every 3 years, assuming the tree grows a half an inch in diameter per year, it's going to cost you $660. So at the end of 10 years, you will have, instead of having a 20-inch tree, you're going to have a about a 24-inch to 24 or 25-inch DBH tree, and spend $660 versus having a 4 or 5-inch diameter tree and have spent $880. So you can have a much bigger tree for a lot less money after 10 years. Those of you who are a little bit more quantitatively oriented, I'm going to talk about the emerald ash borer cost calculator in the context of the ash decline cycle. Okay, so what's an ash decline cycle? My colleague Chad Tinkle is a city forester in Fort Wayne, was kind enough to share the data of tree removals from the time it was first found. They started removing trees from emerald ash borer in 2006 until he finished removing his over 14,000 ash trees that were on the streets of Fort Wayne. And one of the things that one good way of approximating the rate at which trees die is a doubling model. So, if you can imagine that if in year 1% of the trees are removed, in year 2, you would have 2% of the trees removed. Year 3, 4%. In 2009, so you have 8, 16, 32, 64, and over a period of 8 years, you'd have 100% of your trees removed. So we predicted the number of trees using this model and calculated it on this black line, but the actual observed was the blue line. And I don't see a whole lot of difference between the black line and the blue line over here. So this doubling model is a pretty good approximation as to where you are in the ash decline cycle. So the idea is that you want to be able to protect your tree throughout this decline cycle from emerald ash borer, and you can do that by covering them in kind of like a bunker of insecticide. pretty much, you want to wait until the tree is within 15 miles, emerald ash borer is within 15 miles of your trees. So, if it's, so if you are in eastern Texas where there was a report nearby, it might make sense to treat. But if you're in West Texas, it doesn't make an awful lot of sense to treat at this point in time because they're hundreds of miles away from, emerald ash was 100 miles away from the trees at this point in time. Okay, now, early intervention is critical. Okay, we've got this app called the Purdue Plant Doctor that allows you to diagnose tree problems, but we have a nice entry there for emerald ash borer. We have lots of pictures of canopy thinning so that when you're talking with your clients about canopy thinning, they know you're not making this stuff up and that you're using some real references. On the left, we see a tree that has about 10% thin. This tree has a great likelihood of being saved. This tree over here is about 30% thinning. A certified arborist should really look at a tree like this to see, if you imagine the tree without the dead parts, okay, if there's a tree left worth saving, then you know whether you should invest in it. This tree here that has clearly lost, more than half of its canopy, this is not worth saving at all, okay. So we use this 30% threshold as anything that's bigger than that, that's more than that, we don't bother trying to save. And what we wound up doing is we decided to look at the, we decided that we would look at the rate of accumulation of trees that have gone beyond the treatment threshold. And we did this in Lafayette, Indiana, before emerald ash borer was actually detected, and we found that it followed it quite well, except for the year 2012 when we had a really big drought and trees were having died back for other reasons, but they eventually snapped back to the curve. We also did this in Indianapolis, in that one park that I showed you that first picture in that golf course in the beginning of this talk. We started this in we started it in 2011. We were actually sort of to see that at this point in time we knew that we were 6 years into the infestation and that all the trees would be dead in two more years. So, we have this cost calculator that allows you to estimate the costs, and we use this invasion wave model that we just validated, which I showed you before, and you can stage your response based on the percentage of trees that were there. So, for example, if you have 16%, if you say you surveyed 100 trees and you find 16% had lost 30% of their canopy or more, you will be in year 5 of the infestation, and that will be pretty much your last year to. We only have, you can either do it in year 5 or year 6, because after year 6, if you wait to treat after year 6, 2/3 of your trees have already died. Okay, at 64%. So let's say if you got 16% of your trees showing signs, you only have 3 years until all your trees are infested. This is kind of important because we want to use this as a way to wake up communities, because when you only have 16% of your trees damaged, that is which is basically 1 in 6 trees. That is not really very breathtaking in terms of damage, but the worst is coming. Okay, so let me just sort of run a few numbers here to discuss why we are certain that it makes economic sense to protect a tree. So what we did is we looked with a representative forest, assuming that we're using bulk discount for treating trees, and we used the cost of removing and grinding stumps in Indianapolis to estimate what's going on here. And we had 1,600 ash trees, assumed that we're going to proactively, we compared, we wanted to save trees, compare the cost of reactively replacing ash trees, which means removing ash trees as they would become unsalvageable, as they reach that 30% threshold, proactively replacing all your ash over 7 years, or saving all your trees that were of a substance and size, which uses an optimal investment model based on Kent Kovac's theoretical work, where you just save the large trees to optimize your investment in trees to get them of that size. And we assumed it costs $5 per inch to do this. If you're doing it in-house, you would treat once every 3 years, And then after year 10, you would go into a maintenance mode where you would only treat after you saw fresh signs of wood pecks or fresh thinning, and we assume the treatment saved 95% of the trees. And the tree size replacement was 2.5 inches DBH, and it costs $400 to purchase, plant, and replace these things. So what we found is that this graph here is costs on the y-axis, time in years on the x-axis, and we assume you start in year 1. This black line refers to the cost of reactively replacing these things. So basically what happens is that as all the trees start dying in the last 2 years, most of your costs are compressed here. You spread out that cost of tree removal, removing all your trees over time, over an 8-year period. But if you're treating once every 3 years, this blue line here, you see how the costs go each year. The costs are lower and they're spread out over time. If you start late in year 5, you're compressing a lot of these removal costs, okay, so that it's going to be a lot more expensive, $630,000 versus $475,000 in year 7 for removing them as they die. But overall, but after you remove the trees, there are no costs. But what about the cost in terms of the long run? When we project this cost over a 25-year period, we find that over time, this blue line is the treatment cost. If you start in year 1, it is less expensive over 25 years to keep these trees protected than it is to remove and replace all of your trees. If you wait until year 5, it is still less expensive than removing and replacing all your trees. Now, what does this buy you in terms of benefits? Well, if you wait until if you save your trees, you have a bigger forest. Okay, so instead of having lots of little sticks that may be 3 and 4 inches DBH, by the end of the 25-year period, you have some substantial sized trees because you protected the big trees. Same thing happens if you start in year 5. So it makes a lot of sense. You get more tree for the money when you save these things. So I decided in this paper that Matt Ginzel and I wrote, which is on the links that we have for this talk, we took a look at the discounted cost to produce a single linear meter of diameter breast height, and we found that if you started in year 5 of the cycle, all the options that involve protecting trees are far less expensive than what it is to remove and replace them. In this case here, this is roughly 1/3 of the price, okay, to protect your big trees as it does to remove all your trees. If you, for some reason, have to pay $10 per inch, it is roughly half the price to protect to protect the trees than it is to remove and replace them. So any way you look at it, okay, if you're trying to conserve meters squares or DBH as some estimate of the size of the forest, you are saving money by protecting trees. So there really is no argument to say that you save money by taking your losses early and cutting down and replacing your trees. So in summary, starting your management program in year 5 after damage can save up to 84% of the ash, which is the remaining ash, and it costs a lot less than removal and replacement. And this means that if you are living in a community where people have to see a little bit of damage, you can actually direct them to the 1 in 6 trees that are damaged to get their attention. But you have to get your treatment in that last year, or you might be a little bit behind the 8 ball. That year or the year after. Okay, so that brings me to the point. How do you call awareness to emerald-ash borer and get the community involved? Okay. All right. Well, this is the fundamental problem of emerald-ash borer. These trees are asymptomatic, and they are infested with emerald-ash borer to a very, very low level. And this is when you really need to act, and this is when it is most difficult to motivate people. All right. And I took that picture 400 yards away from this a dead ash tree that I found in a parking lot. Okay, right at that site. So this blue arrow over here is where this is where those healthy trees are, and this is where I found the tree. Okay, the previous fall. Okay, So it's hard to detect infestation early in the curve, but that's when you really have to act, and you really want to act pretty much before year 5 over here, okay? But on the other hand, it's really easy to detect later on in the season. Here we see all the trees here have lost more than 30% of their canopy here, all right? But, you know, once you get to this point over here, it's too late to save anything, okay? So it may be easy to notice late in the game, but it's really, really hard to get people to act. So how do you get things moving? Years ago, we set up this program called the Neighbors Against Bad Bugs program, which was a way to stimulate communities to get people to act. And it involves, we've done a number of NABs over time. In 2008, we started with Fort Wayne having community bids, okay, and then in Indianapolis, we had a project in this King Park in the Bate District, and in 2016 in Shelbyville and in Evansville, we have Adopt a Tree programs where we have communities pooling their resources to reduce the overall cost for protecting the trees and winding up saving. They are actually able to get the money they need to protect their forest. Okay, so let me just sort of pull this all together in a nice graphic. Okay, so these diamonds over here are referred to as a theoretical population of emerald ash borer. So it's in an area you have, and this is the percentage of the maximum number of emerald ash borer you're ever going to see. First is there's a few, the populations get bigger and bigger over time, and then eventually when all your trees have lost more than 30% of their canopy, we start hitting the peak of the emerald ash borer. Then as they start depleting the emerald ash borer resource, their abundance goes down, never to zero. They persist at low levels, but they're always there. Okay, so here's your 8-year cycle of destruction, these black squares over here. So when you find emerald ash borer in your county, you want to really lobby your community to start getting control. You really want to get that control pretty much by year 5 at the latest. Okay, that's the 16% over here. Okay, it gets dicey beyond that. Okay, you know, what I would do is I would just use I would choose some sentinel trees where you would just always monitor the trees to see what's going on, so you know where you are in the cycle. And then after this year 10, you know, because in the first 10 years you're treating once every 3 years, okay, and then which means you're only treating 3 times in the first 10 years, and then after that, you know, you would look for fresh woodpeckers, and once you see them, you might treat once every 5 years, so you might treat, you know, maybe 2 or 3 times afterwards. So this is sort of my vision for the long term. We have developed these guides called the Emerald Ash Borer Decision Guides. I am more than willing to share this with any state that wants to post this on their website. I've done this throughout the country already. This was developed by Anne Marie Nagel and I, where it's just a schematic that says, you start with an inventory of ash trees so you can assess the extent of your problem, decide whether or not you want to save them. If you don't want to save them, start getting ready to pay for removing them because you don't want them falling down on people and killing people. You know, if they're worth saving, you want to start planning a treatment program. You should get homeowners to hire tree care professionals. This treesaregood.com is a nice International Society of Arboriculture site that helps people hire professionals. Another thing that we have is the Purdue Tree Doctor apps at PurdueTreeDoctor.com. Allows you to get information about the emerald ash borer. It includes this nice schematic over here that helps you show people where they are in terms of if they've exceeded or gone below or not yet reached the threshold. We've got individual photos of different levels of canopy thinning so they can actually match it. And this really is kind of helpful. Lots of times, you know, people who don't know anything about emerald ash borer and don't know anything about trees have an arborist who they don't really know all that well giving them information about trees. If you got an app that says this is from a university over here, that can certainly help build the confidence, okay, because they know you're not making this stuff up as you go along. And finally, the last thing I want to say is that we have a bulletin called Insecticide Options for Protecting Ash Trees from Emerald Ash Borer that gives you all the details on how to protect ash trees. Deb and I are going to be, Deb McCullough and I are going to be reviewing, revising this thing. We hope to have something out before June of this year. That will include some of the more the recommendations that I have in this particular presentation. So with that, I will answer questions. The first question I see is, how is the second edition different from the initial release? We include information about the emerald ash borer cost calculator and other things. The new release will be out hopefully in June, and we're going to talk about, because in the previous editions we had just anecdotal evidence that suggested that you could protect big trees. You know, after the study that I have done in Indianapolis, we know for sure that there's no limit to the size of a tree that you can protect, and this is really critical.
You are currently the only person in this conference.
The only person in this conference? Okay, sorry. So at one point in time, I was in Iowa, and I was asking folks why aren't they planning to treat their trees, and they said, well, if you can only protect trees that are up to 25 inches in diameter, you know, why not protect them now? Why not remove them when they're smaller, because it's less expensive? Well, that made a lot of sense, but now that we know that there's no limit to the size of a tree you can protect, you know, it makes a lot of sense to keep them alive, because you get a lot more value from that trees in terms of ecosystem services and the like. Okay, so now I'm ready to go through questions that we have here.
So the first one actually is,
and he asks, could you explain again how the tree is dead when it has leaves on the interior of the tree?
Oh, okay. Well, okay, how can we do that? Okay, so so how does this work? Okay, the tree. Okay, so you want to think of it like this: your large tree has to be supported by a vascular system, all right? And then the emerald ash borer cuts off the vascular system, and that causes the canopy to die back. All right. Now, and then what happens is that initial stem will die. All right. And as it's dying in its last throes, any bud-like tissue that's near the trunk is going to pop out and start sending off a shoot. All right. And some of those shoots actually come off right where the trunk of the tree hits the soil level, okay? And, you know, in the forest when this happens, this is called coppice planting. In other words, what happens is that the shoots that come out from the dead trunk, you know, you could actually, if you remove that dead trunk and saved some of those shoots coming out, you can actually regenerate a tree out of that one over there. But the thing is that after that tree dies, okay, most of the emerald ash borer have left, and you'll have several years where the density of emerald ash borer is going to be somewhat low. All right, and that means that you know, those trees can grow for a while, and those shoots will eventually become a tree. But that tree that generated those shoots is dead. Does that explain it? Oh. You still there?
I'm still here.
Great. Okay.
All right. So Gary Fish asks, what is the risk of EAB resistance to imamectin benzoate?
Well, okay. Resistance. Resistance is a really important question, but irrelevant to the emerald ash borer at this point in time, because we are treating such a small proportion of the ash trees that most of the emerald ash borer are not ever going to be exposed to that insecticide. So any resistance that could occur is going to be diluted by the general gene frequency of susceptibility in the general population. Okay, so it's not like we're treating every single. It's not like we're like the folks who are planting Roundup Ready corn and Roundup Ready soybeans, and then putting Roundup on their farms for 25 years in a row, where every single weed in that farm is going to have to make it through, it's going to be exposed to Roundup. This is nothing at all like that.
All right, another question from Peter Smith. Please address impacts of imamectin benzoate on non-target insects. Does the chemical remain in leaf litter? Is the sawdust risky for woodworkers?
Woodworkers?
Yeah, woodworkers.
Woodworkers. Okay. All right. Well, let's address the woodworkers first. The product, well, first of all, imamectin benzoate, okay, so the product, okay, that, so the product only goes, these are ring porous trees, so the product is only in that single ring that was treated, okay? So if you're treating it 3 times, okay, you know, there may be some residue in there, but most of the material gets taken up into the leaves. The other thing is that I don't see that people are going to spend money to treat a tree just to cut it down. So I don't think the likelihood of having woodworkers are exposed are also there. So first of all, there's very little there. Second of all, it's not likely that they're going to be treating a tree and then cutting it down and making wood products out of it. Now, in terms of decomposition, the material is taken up in the organic matter. It is not, you know, it can probably harm some of, like the leaf tissue could probably harm some detritivores, detritivores insects, but you want to weigh the impact of that on what would happen in the absence of a tree when there is no detritus for the detritivores to feed on. All right. In terms of pollinators, there's been some research that's been done on this in Ohio. We have this at Emil Nashbour University on the impact of pollinators, and we found that Reed Johnson did this work, and he could not detect imamectin benzoate in the flowers of the ash trees. Also, ash trees are wind pollinated, and bees are unlikely to take the pollen unless they're raining pollen on top of beehives just beneath, you know, that are placed just beneath them. So, you know, so the non-target effects are minimal. And you know, so in terms of, especially if you're injecting the tree, you know, you're not going to have runoff into streams either.
All right, Bioforest says, please mention the importance of trapping from monitoring population density.
Okay. All right. Trapping to monitor population density. Okay. I am in the part of the world where I live, where Emil Nashbour is all throughout the state. You know, population monitoring is somewhat meaningless. Okay, when it comes to thinking about applying the azadirachtin products, because basically it's everywhere. All right. Now, if you are in an area where Emil Nashbour has first come, and you, in order for azadirachtin to work, you have to get that product in early. As I said earlier in my talk, is that azadirachtin works quite well on trees that have yet to show signs of dieback. Now, because dieback, canopy thinning, occurs after Emil Nashbour has arrived, you know, a good indication of when it is good to use start using the product is when you're starting to catch your first beetles. So if you're in a community where the beetles are first being caught, you start catching your first beetles, that's when you want to apply before you start seeing the dieback. Okay, I do not know of a number that is of a particular threshold, but that's the concept. It's just, I think you know, the Bioforest folks are absolutely correct in saying that you really want to get that product in early before Emil Nashbour has actually started damage. In February of 2017, I gave a talk called Emerald Ash Borer, called Chemical Control for Emerald Ash Borer: What Works, What Doesn't, and Why. It's on Emerald Ash Borer University. Just Google Emerald Ash Borer University, and I go into a lot of detail about the timing and the like. And that information will also be probably in the revised insecticide options for protecting ash trees. That's in the front screen right now.
All right. So actually, like, that's the perfect seg for this question by Tara Constanzo. So how is the second edition different from the initial release? And I assume she's talking about insecticide options for protecting ash trees from
the second edition has more information about, we now that the second edition has more data on knowing that we can protect trees that are larger. And the third edition will actually say that it's unlikely that there is no limit for size. It's going to be a refinement. And the thing is, you can download this stuff on the web free, so you may as well use the latest edition. This is all research based.
So she also asks, will it include how symptoms are different out west versus the central states?
No, it will not include how symptoms are different from western states. I am not aware of any publication that documents that the symptoms are different. And if she knows of one, I'd be happy to hear about it. But I don't understand how it could be different. The borer cuts off the circulation of the tree. This tree starts to die back. The thing that might happen is that in the presence, if street trees are indeed irrigated regularly, then there should be very little difference. If the street trees are irrigated irregularly and they have extensive periods of drought, the rate at which the trees die may accelerate, maybe faster.
So Tara, if you have any literature on that, be sure to place that in the chat box. So Bob Hammond has a question. Is there any research on dinotefuran trunk injections?
Dinotefuran trunk injections. Yeah. Oh, that reminds me. Okay. In terms of trunk injections, okay, there is a so the injection methods that seem to work quite well are well, actually, there's one injection method that does not work. It's the Wedgel device, which looks like a hypodermic needle. Okay, and it does not involve drilling. What happens is the company that's selling this says that drilling causes a lot of damage to the tree, and that they just pluck out a piece of bark and then they inject it beneath the bark. That can actually cause the bark to actually separate from the trunk and cause a wide amount of injury. Plus, those particular products, it's called Boxer, I believe, is the product that's being sold with that thing over there. It only has 1.5 mils per inch DBH, which is far below the rate recommended for protecting trees. So that does not work. So stay away from the Wedgel product, the Boxer product, because that product does not work. The other products that have emamectin benzoate, the 4% emamectin benzoate, will work. Boxer is a 4% solution, but the problem is that not enough product gets into the tree to actually protect it. The other products, if you're injecting this thing at 5 mils per inch on big trees and 2.5 mils per inch on trees that are less than 20 inches in diameter, you're going to get great results.
All right. James asks, where will the EAB go next after all the ash are dead? I mean, hopefully it won't come to that, but...
Well, all the ash are never going to die. and I think that's because there is a game of cat and mouse that's being played between host plants and bugs. The ash trees, their ace in the hole is that they won't be attacked unless they are thicker than your thumb. Okay? So in the forest, these thin seedlings can have 4 years, especially in the dense forest, 4 or 5 years before they can reach an age where they can be attacked. And that means that when all the populations of emerald ash borers are pretty much gone, it's going to take them a while to build up their population again. So they could easily get up to 4 to 5 inches in diameter before they can be attacked again. All right, and so what's going to happen is that the emerald ash borer goes to areas where emerald ash borer has never been, and there's plenty of ash, and then there's some backwash, you know, in the back way, in the reverse direction of the invasion wave that allows them to sort of persist. Also, there's some work that's being done on the biological control of emerald ash borer that will protect trees up to 5 to 8 inches, maybe even 8 inches in diameter, especially with some of the newer parasitoids that are coming out. And then it'll be possible to have ash trees that may be as big as a foot in diameter at some point in time. So I think that between the natural enemies, slowing the rate at which emerald ash borer populations can build up again, and the natural the age class of where small ash trees are unattacked, can't be attacked by emerald ash borer, that's going to allow the ash to persist, and the emerald ash borer and the ash will persist in perpetuity. How big will the trees be in the future ash forest? That is something that is a hot topic of research at this point in time, and we'll probably know in a couple of years. But I would guess think of the elm trees. Elm trees used to be really big, and now when Dutch elm disease is there, now the elms in the forest, they pretty much die after 8 to 10 inches in diameter. That might be kind of the scenario we see for ash trees. If not, maybe the ash trees might be just a little bit bigger. But I couldn't say for sure.
All right, Laura asks, can we assume that treatments after year 10 are only maintenance treatments every 5 to 10 years?
Yes, I think that's a very good assumption. If you wait, after 10 years, we assume in the model, in the article that we have a link to, that's drop my mic. The model that we linked to, I used that assumption. So in the first 10 years, I treated once every 3 years, and then afterwards, I treated once every 5 years in the maintenance period. That's pure speculation on my part, but given what I know about, I've seen enough ash forests that people have stopped treating, and after the emerald ash borer went through, and the trees can grow to a pretty big size before they're killed again. So I think that's probably a conservative model, conservative estimate.
All right, Jared asks, how effective is Prism trap monitoring for early detection of EAB?
Prism trap monitoring. I think a lot of it has to do, what colors your Prism trap? What lure are you using? I need that information. So you want to use the right lures.
So okay. Jared actually says green Prism.
Oh yeah. Oh, the green Prism trap can be quite effective. Okay. It can be. Actually, some of the work that Deb McCulloch and Therese Poland did on the Prism traps, so if they're placed in a sunny site on the edge of a forest, it can be quite effective. It can be quite effective, especially when they're using the manuka oil traps and the correct plant leaf, green leaf volatiles. So yeah, the most effective trap really is a trap tree, but in terms of being able to attract beetles. But in terms of being able to monitor the beetles, it's not as easy to peel trees as it is to look at a trap, and those green Prism traps are quite effective. They're a lot more expensive than the purple traps that are used by a lot of the regulatory agencies, and that's that factors in the decision of which kind of trap to use. But having those purple traps are definitely much better than no traps at all, for that early detection.
So there seems to be some concern about emamectin spreading in wood chips. So somebody talks about that. Is there a public risk? And then another person asks if there are any actual studies about that.
Well, once again, I want to bring that whole thing up, is that why would emamectin benzoate be in wood chips unless that tree was killed by something other than emerald ash borer? Okay, so it's not going to be in wood chips because the emamectin treated trees are going to be alive. All right. Now, in the offset where there's a lightning strike or a tornado comes through and it blows down a couple of treated ash trees, I mean, there may be something going on there. But, you know, when we start talking about risk, we have to compare risks. All right. So we do know that when we don't treat those trees will die. Okay. And if just a very small proportion of the trees that are treated are dying due to weather or, you know, snow plows hitting trees and things like that, and they have to be chipped. And then you know, there can be some risk, but remember, it's only going to be in those rings where the emerald ash borer where the product was actually being conducted up. You know, when you inject these trees, you're injecting them, you know, on the root flares and within like, you know, 6 inches of the soil line. So so where it was actually injected, where the plugs are, I mean, you're not going to be chipping, you know, that up.
The EAB has not reached my location yet, says Matt. Are there any steps that can be taken to prevent infestation?
Yeah, well, the steps to prevent infestation is to not import firewood from places where emerald ash borer is. Okay, emerald ash borer moves at about 1 kilometer a year. Okay, by natural spread, and it's just when folks in pickup trucks spread it around as firewood when it actually moves pretty fast. You know, it's kind of one of the great ironies. You know, people, you know, want to go to beautiful areas and take firewood with them, have a nice campfire, so they take a tree that died from something, chop it up in little bits and take it to that place to make a fire. Now, you know, unless you're going to burn that wood quickly and and completely, you know, you do stand a chance of taking whatever killed that killed that tree in your backyard and bringing it to your favorite park. So definitely don't move firewood. It's probably the most important thing that you can do.
All right. Dean asks, what is the most affordable type of treatment?
Well, that really is the most affordable type of treatment for a homeowner. If you have a tree that is less than 15 to 20 inches in diameter breast height, you can go and apply the soil-drenched Imidacloprid. Works quite well. You know, as you approach 20 inches, your efficacy goes down. All right. But the thing is that so you can buy a quart of product. It's normally about $20. At the end of the season, it might get it for 10. Okay, and a quart of product will treat a 10-inch diameter tree. All right. If you are a municipality, it might make sense to train your folks to treat the trees yourselves, so you're paying for product and labor, and not paying for what a contractor would do to come in for that sort of a thing. You definitely want to have a couple of bids, like anything else. And I think if you're treating at 5 mils per inch, all right, if that stuff costs 50 cents per mil, okay, and then you know, you say on a 20-inch tree that's 100 mils, you know, it's like $5 worth of product. Okay, so you know, it's not going to be that. You know, the thing is that it is. I mean, I blew that math, so I don't follow that. The thing is that if you are treating less frequently, once every 3 years, okay, and it costs say $10 an inch, that annual cost is $3 per inch. Okay, so you have to sort of play around with that. Now, the thing is that what I would do is, if you really wanted to play around with some things, I would play around with the emerald ash borer cost calculator and put in some prices per inch for treatments to see how that affects your budget over time. And we designed it so you can actually see how that impacts your annual budget as well as cumulative costs over different periods of time.
Douglas asks, are any of our native species of ash more resistant to EAB than others, or are they all equally susceptible?
No, it turns out that blue ash is highly resistant to emerald ash borer. It will, blue ash will survive. So there's been some studies in Upper Michigan, and we did some work here in our lab down in Indiana, where we found that blue ash, I mean, emerald ash borer adults just don't like blue ash. The adults don't like to feed on blue ash. They don't like to lay eggs. In common garden studies, they don't like laying eggs on blue ash. And in forests of mixed stands of green ash and of white ash and blue ash, most of the white ash die, the vast majority of the white ash die, and the majority, the great majority, like 70% of the blue ash survive, according to some work done by Deb McCulloch up in Michigan. So, and then there's also a very low frequency but significant frequency of white ash that can actually survive the forest. Okay, but survive in the forest, but it's not, the vast majority will be killed, and there's some work that's being done looking at the frequency of the white ash. But for the most part, in cities, the cultivars that are planted on the streets, they are, with the exception of the 1 or 2 blue ash cultivars that are being used, they are all susceptible. Okay, if you're growing a Manchurian ash, it is resistant to emerald ash borer, but susceptible to the native ash borers, like the ash clearwing moth. Hello?
All right, we are kind of, coming to an end here. We're almost at 10 minutes past the hour. So Rick has some great comments about how successful emamectin has been for the Cleveland area. And a few other people have comments, but I'm not seeing any other questions. So I think I am going to call it here. And thank you, Dr. Sadoff, for the great webinar.
Thank you, Brent, for helping me out today. Appreciate it.
Would you like to give everybody your email address so they can ask you questions?
Yep, my computer went to sleep while I was so busy talking. So I have to log back in. Okay.
All right. While he's doing that, I am going to push out the link for the continuing education credits. I'm going to put it in the chat box, so y'all can click that. For most of you, if you leave the webinar, it should just come up. But otherwise, click that link. It should work. I also am going to use this automated system right now, so you may actually get this coming up right now. And otherwise, if you all have any questions about continuing education credits, please email me at bpeterson@srf.info, which I'm also putting in the chat box.
Okay.
And I think that's about it, unless you have anything else to add.
No, I just also put the PurduePlantDoctor.com is the link for the Purdue Plant Doctor app, in case somebody wanted to put it on their phone. So these webinars are going to be are archived and posted. Is that correct?
So these webinars will be archived and posted. All of them are currently archived. All the previous ones are archived and posted at southernforesthealth.net/webinars.
Okay.
This webinar will be available in about a week or two. It takes about that long for this program to archive them for some reason.
Okay, that's great.
And if we have no further questions about CEUs, I'm going to stay on a little bit, but Dr. Sadoff can leave. Again, thanks again for the great webinar.
Well, thanks. There's a huge crowd. I appreciate it. Thanks for having me.
All right, and everybody else can leave. Or, again, if you have some sort of questions about the CEUs or whatever, I'm going to stick on for just a few minutes, probably, here. For instance, seems like Susan's asking where the CU information is, and Susan, the CU stuff will pop up once you leave, or you can click here on the survey. You have to take the survey and do all the other bells and whistles before you can actually get the CUs. The slides are actually up on the page, so they're up on the webinar page. So just go to forestrywebinars.net/webinars/planning-and-timing-r critical, etc. All of the dashes. I'll just put that in the chat box right now. And in terms of the economic value, just whatever you feel it was worth. I suggest over $1 million.